Well, good afternoon, everyone. Lovely to see you, everyone joining in. Just give it a couple of moments to for everyone to get onto the call. We've got high attendance today. We've got a lot of quite sparkling names out there, and from all over the place. We've got some old friends and some good colleagues and some new people as well. It's lovely to see you here. Hi, Adam. Good to see you. Yeah, it's going to be a good session this afternoon. Well, your part is. Let's see what my bit does in a moment. Okay. So just before we get down to it, this is a 1 hour session. I'm going to try and get through the slides as quickly as possible. Quite a lot to cover because we're going to look at the DISCAS standard, but move through the kind of the main parts of that to look at it in a bit of a wider context, but in particular for the new sort of disciplines and impacts that the Teams rooms, the Microsoft launch of the new Teams room front row is going to have on that, and also a bit of wider context as well. I'm going to keep this as ever strictly within the hour, but I want to do some Q&A at the end of this because I hope everyone will be prepared to do that, because I don't see the things I'm going to talk about as a slam dunk in any sense of the word. I think this is very much a changeable situation, and I think it'd be really good to have some conversations about that. So this is the 5th in a series I've been doing, really off the back of all of the interest there's been around about hybrid spaces in general, but honestly, Teams rooms in particular. Microsoft has put out a lot of thought leadership into this space, and it does apply, across the board. But anyway, let's get going now. We've got people are still coming in, but it's all great to see you. So if anyone could keep questions and comments going in the chat and in the Q&A column, that would be great. Good afternoon to you, Wolfgang, too. It's good to see you too. Right, let's get this show going. Okay, so as I said, this is the 5th in a series that I've been doing. For those of you who don't know me, I'm Greg Jeffries. Thank you for being here. I'm the owner and director of Visual Displays. We used to run under the name of Paradigm. I'm a specialist consultant in my particular areas, standards, displays, lighting, particularly VC lighting, and also heavily involved in teaching space and meeting room design. I'm not an AV consultant. I actually do a lot of work for and with AV consultants, and I'll talk about how myself and my company operate in the channel, but that's important to say. A lot of friends who are AV consultants on the call today. I want to get that clear. I currently lead Avixa's standards committee, standard steering committee. That's been a group that maintains and commissions the new standards that we do. I wrote the DISCAS standard, that I co-wrote the DISCAS standard that is in this suite of standards. And this DISCAS standard, I moderated that task group back in the day. Currently working on a new UX for AV design standard. That is be a very interesting thing for everyone to get engaged with, and that will be something that I'll be doing some webinars when the time's right. I've been involved with VIX's leadership for a number of years. I was president in 2012 and also on the board for 6 or 7 years. And that is me. So we're going to talk today about the display image size for 2D content in audiovisual systems. And you can see why we tidy that down and call it DISCAS. So the standard itself, the scope of the standard, it's about being able to calculate the minimum image size that's needed relative to where the viewers are going to be. Like a lot of VIXA standards, it's not about any components, it's about the overall system. And we're not speaking to any particular component in it. And we use 2 of the 4 viewing categories that we have in the DISCAS standard, the projected image system contrast ratio standard. That, by the way, is about to become ISCAR, because that's going to become an across the board display standard. So for our objectives today, because this is a CTS, renewal point course, we can do it there. The objectives that I'm aiming to cover with and for us this afternoon are that we're going to be able to plan and design new display systems from what we talk about today. We're going to be able to determine the image size relative to the space and where the viewers are going to be and their viewing requirements, to be able to speak to the closest and the farthest viewing positions, to be able to define where the horizontal angles of view are, to talk about resolution, where that's applicable, that there's a kind of a caveat there, and also to provide metrics for content design, which is another way of saying that this standard can be used for existing systems too. One headline point to make at the front end of this is that we're talking about image size in terms of the image height, not the width. There are all kinds of aspect ratios, and we're going to be looking at some of those this afternoon. And the image height is specified relative to the farthest viewing position. So there's no change there from the original, the old CTS training materials, but there are brand new metrics involved, and we're going to look at those today. So the DISCAS viewing categories, we've taken 2 from the 4 out of PISCAR, the projected image system contrast ratio standard. The first one, basic decision making, honestly, that takes care of just about everything. I use this standard all the time, and my business is displays. Honestly, very rarely do we actually use the standard for analytical decision making. I'll come into that in a bit more detail. But the main points about the basic decision making category is that this is about viewers being able to make decisions by reading and engaging with content. It's based on an element, which we call which is a kind of a neutral word for a character or a font, and we use the percentage element height as a principal metric, and this is the height of an element in relation to the overall height of the image. Analytical decision making. That is where viewers can make decisions by seeing the finest detailed display. So that's going right down to granular level, right down to pixel level. And for that reason, that's the viewing category that is that relates to image resolution. So we're going to look at what element height means in practice. Hopefully this will fire up here nicely. Good. So what I've done here is I've fired up an executable PowerPoint file. I can share that with you after the course. This was a piece of work that was produced by Dick Tolberg, who now works for BIAMP. Dick, I have to say, give credit, was the superstar of a really fantastic team I had writing this standard. and Dick did pretty much all of the math and did other work pieces like this. And we offer this out as open source. So looking at this, looking at these slides, what you can see, looking at the top left, you can see a percentage number and also a number before that. The number before that relates to the font size, but that's academic interest really. It's the percentage element height that is the important thing. And just to be clear, we'll look at that in a bit more detail in a moment. But what we mean by percentage element height, and that is the height of a, let me just get my little annotation tool up here. And that's the height, of lowercase characters relative to the overall height of the screen. So in this case, the lowercase characters here are 3.5% of the overall height of the image. Now, we use PowerPoint. It's actually a really handy tool because what's different about PowerPoint relative to Word or Excel is it can scale. And so you can use it on any, you can use this this program, this executable program on any display. And the point about doing is you use this to engage with the users. There's no such thing as one size fits all. And so an important part of the process is to go through this slide deck with users of the system. We've got Piet van der Zanden on, my friend from TU Delft on the call. He's done some very detailed work on that. But the point is, a lot of university campuses, for example, have done this work, and they've come up with their own percentage element height, or as a subtended angle of view. But it's a very good thing to work with this, because you get very good buy-in. You get a better answer, and you get better buy-in from your users as well. This is something that that kind of thought, something that you're going to hear more and more of as the new user experience design for AV systems comes into effect. So that slide deck, it will be available to you after this as part of the packages. I have them as slides in here just in case we want them, or in case my system falls over. And again, just to be clear, or to be absolutely clear in our terms of definition, is that the element height is effectively equal to the X height. And in typography, the X height refers to the lowercase character height. Now, although I do strongly recommend that you use that PowerPoint file, or you can write your own version of that. Although why reinvent the wheel is it's a very good tool to use. In general terms, if you don't get the opportunity to do that, then the widely adopted norm there is to start with 3% element height as a starting point. And the neat thing about that is that that actually loops back very neatly to the old 468 rule from the old CTS teachings, where this is where the 3% element height equates to the 6 times rule. That is to say, the farthest viewer to be no more than 6 times the image height from the screen. So if the image height is 1 meter, then the farthest viewer should be within 6 meters. And that's the one thing that is kind of a bit of a theme now, particularly as a result of what I'll be talking about in more detail as we go through, is that it's talking about the minimum image height. It's not talking about what the image height should be. It should be what the minimum image height should be. So leave that thought hanging there for the moment. And just moving on then. So the first thing we're going to look at is the closest viewing positions, which fall into two parts. Now, firstly, there is the closest viewing position that is set by the vertical viewing angle. Now, when we wrote the standard, we unexpectedly had to go back right to first principles, because we wanted to look at the original learnings and references that the original CTS education material came from, but we couldn't find them anywhere, so we had to start again. But however, having that fresh look meant we also looked, cast our net wider. But there were some really very useful other standards that we could use as normative references in the standard, and not least for this one. So there are a lot of there's a lot of unanimity in the standards out there, saying that the closest comfortable position for a viewer is that a viewer shouldn't have to look further up beyond 30 degrees above on axis to the top of the screen. Beyond that, you have to move your head back, and that you might cause neck strain and so forth. But this is basically taken from normative references in existing ergonomic standards, and there's nothing revolutionary there. By the way, that if there's quite a useful number there, and you can work it out as an offset, which you'll see in the calculators we'll look at in a while. If the eye height is level with the bottom of the image, then there's that ratio of the image height times 1.732 to set that closest distance. You can do it with trigonometry, but you can also do it with that number, use it with that, and describe the offset as well. But we'll look at that on the calculator. Spoiler alert, we're going to look at calculators, and they really do take, although it's important that you know and understand how the standard works. This is not something you need to write copious notes about, because we have got calculators, and apart from anything else, I'll be sending you this slide deck and all the other materials that we're looking at as well after that. So that's the closest viewing position being determined by the vertical viewing angle. But there's another part of that. There's the closest viewing position that's determined by the horizontal viewing angle. Now, one thing that we did change, which was a big departure from the original CTS study works, is that I don't know if you remember, but you would have the viewing angles drawn from the center of the screen. There was like 45-degree triangle that was drawn from that. But what we said when we were formulating the needs for this standard is that it was really important that viewers should be able to engage with content for the whole of the screen area, not just the side closest to them. So again, looking for other normative references, it was determined that the horizontal viewing angle, which would set the limit for the front row, if you like, would be the 60-degree angle from the far end of the screen. And what you see is that you get that typical shape, which is you get that straight line. Whoops. You get that straight line that is set by the vertical viewing angle, and then this angled line that is set by the 60-degree from the far end of the screen. Now, one thing to be clear about here is that, and this kind of is a general point that I like to make about standards, is that if, for example, you go to 61 or 62 degrees, for example, it's not as if viewers are not going to be able to watch that. There is some elasticity here, because it's not a binary proposition. It's not as if you step from one position in the room to another position in the room you can't see, but it is about making the optimal viewing experience for everyone that's there. But I think this general principle in 2022, seeing how standards are going to develop, then this understanding that you can use them critically and you can take what you want with them and use them, it's absolutely legitimate. Oh, my mouse is going absolutely crazy this afternoon, but I'm going to blame my mouse and not me anyway. So this is what a kind of a typical viewing plan involves. So what we have here, you can see the line that's been the closest line that's been set by the vertical viewing angle. You can see that fillet that's been taken off the front there from the horizontal viewing angle. And then when you have this 5 times or 6 times image height, remembering that in this case, or if, as an example, the 6 times image height equates to the 3% element height rule, then you see that you've got 2 arcs. So you've got an arc drawn from one corner and drawn from here, and then it bisects the arc from the other corner there. So you get this kind of odd size. Now, again, you know, that is not to say, that it does not say that you have to have the chairs in the back of the room set you know, set at those sorts of angles. You use this standard critically, and that's something that I really can't emphasize, you know, enough. So, you know, those are the principles of the standard, but there is some complex math there, but it's not necessary for, you know, for us to hold that in our heads or to have to use it and create spreadsheets, because the spreadsheets are, you know, are there already. So what I'm going to do is I'm going to show one of the 2 calculators that are available. This is a calculator, an Excel calculator. Again, the lovely Dick Tolberg wrote originally. There is also an online calculator on the Avixa site. I prefer this because I find it more portable, and also it's got a bit more detail in it. But they're both absolutely legitimate and can be used. Let me just kill my annotating tool. Right, so hope everyone can see this okay. So this is the calculator that we use for basic decision making. And before we start using the calculator, there are 2 basic metrics or entities that we need to put in. One is the height of the standard eye level, the eye level in the space that you're considering. You know, here in the UK, we tend to use 1220, which equates to 1220 millimeters, which equates to 4 feet in old money and in what our American friends use. And then secondly, entering the image aspect ratio, but doing it as a ratio. To 1, so 16 to 9, the most common aspect ratio, that equals 1.78 to 1. And the way the calculator works is that you need to input 3. You need to input 3 of the metrics in order to get the 4th. So basically, it's the same formula, but it's just arranged in each case so that that one of the 3 metrics sits on the right-hand side of the equal sign. So here we can see we've set up the eye levels being 1220. We've said our aspect ratio is 16 to 9, namely 1.78 to 1. And the image height we can set to whatever we want, but let's call that 1250. The baseline of the image, the distance from the floor to the bottom of the image, we can call that again whatever we want, but we can change that around. And there you can see that's expressed as an offset in that cell there. And you know, so that we can see here that that we've also, sorry, the other thing that we've put in is that we're using a 3% element height. And that equates to 6 to 1 as a viewing ratio. If you change the image height to 1000, you'll see that the farthest viewer then equates to 6 meters. So that's how you work out the farthest viewer. In the next one, to work out the minimum image height, again, you put in other figures, put in 1200 here, put the farthest viewer as 9.5 meters away. Change the percentage element height to 2.5. You said tapping away. And then that tells you what the minimum image height is. Very usefully, the minimum element height is part of the package, and the reason that's useful is because it's particularly useful for existing spaces. The standard can be used as a guide for existing spaces, so that you can put in the key metrics of a space in terms of the the 3 boxes we need to fill in here. Very straightforward. The image height that we have in the room, the baseline from the bottom of the image to the floor, and the farthest viewer, and you can put in anything you want there. But then that will tell you what the minimum element height should be. So for anyone who's presenting or lecturing, teaching, whatever it is, they can be given a guide for what the content size needs to be in order to be able to reach the back of the room. It's a real display. It's a real room design 101. It's so important that you don't design inadvertently, but you don't design in cheap seats into the space. It's really important that you deliver content right to the back of the space and people can engage with it. Then the analytical decision-making calculator is really very much simpler, because this is set like the rest of the standard on human visual acuity. Now, we've simplified this in the standard, but using maths, using trigonometry. But we've worked on the basis of 20/20 vision. Now, an important note here about 20/20 vision, that's often used as a kind of as a reference point for having really good eyesight. In fact, that's not the case. 20/20 vision is a sort of is a very useful metric to use, because it refers to the average eyesight, the visual acuity of 60-year-old people. So because young people, kids' eyesight is way sharper than older people's. If you have airline fast jet pilots, fighter pilots, they've got to have visual acuity of something like 20/11. But by the way, it's this 20/20 metric as an example. It's basically saying from 20 feet you can see 20 minutes of arc. That's a third of a degree. That's the smallest detail that you can perceive. And if you have good if you've got adjusted eyesight, I wear glasses, I'm short-sighted, my visual acuity in that case is around 2011, 2012. So here we put in it works in the same way, except you only need to have 2 metrics. We can say our image height is 1500 and the vertical image resolution is 2160. That's UHD, obviously, and here it's really very simple, because it's to do with with how far away you can see an individual pixel, and it's all predicated on that. So like I say, the on the Avixa site there's an online calculator as well, and that action button will lead you to it from the PDF. But you're welcome to use either. But they do make life easier for you. Okay, so that really takes care of the main parts of DISCAS that you need to know about. If you look at the standard itself, you'll see that there's a lot of verbiage in it, but it's very much about justifying the standard itself, talking about the the reasoning behind how it was scoped, why we excluded certain things. Like any other standard, the center of it is a very it's a kernel of just really useful information, and then the calculators that go with it. Within visual displays, we use the DISCAS standard. It's part of our daily bread. Visual displays. We do what it says on the tin. And what we've done is that we use parametric 3D CAD software. And various softwares, but the various apps, but we've programmed it in so that we can help clients to look at spaces in plan view, in elevation, and also in the form of rendered 3D visuals. That's just another way of using it, but that's something that just as I say, DISCAS is very important to us. So we've got it. We've got various tools and models for using that with our clients. Just going to take a bit of a water break. See, we've got a couple of questions in the panel. So Pete, you asked, in the calculator, standard eye level is set to 1220 millimeter. Wouldn't you set that dependent on the viewers? For example, children versus adults. Using an anthropometry database helps us determine that eye level. See, for example, okay, so that's the link that you sent out on the to your website. So to answer that, yes, Pete's absolutely right. That's the point about it being adjustable in the calculator, because there's no such thing as a standard person or as a standard situation, and it is very important to take these to when you're using the standards to doing it on a case-by-case basis. Pete, with your permission, I will share that link with the group when I send out the materials. But as you say yourself, it's a bit elastic. But thanks for that, and I'm glad I dived in at that point while it was still hopefully fresh in all of our minds. Just have another quick look. Oh. I think I was saying that we weren't showing the slide deck, but I believe I am showing the slide deck. Let me just double check this. Is everyone seeing my the slides okay? I'll keep the chat open. Okay. Well, apologies for that if that was not there. Okay, well, hopefully we're back on track now. We will have the slide deck sent out, so apologies if there was any incompetence on my part. Okay, so now moving on. So I was showing you there on the according to DISCAS, what the importance of when we use DISCAS for resolution. But I just wanted to talk in a little bit more detail about this. And this is not part of the standard, but it's part of what I use for my teaching. So just a couple of comments there. So when an image is static, such as on an Excel sheet or PowerPoint, then HD is just fine. But the human visual acuity, it's cumulative. So as objects move, we're adding detail. And so the difference between, for example, HD and Ultra and UHD, also known as 4K, on a static image is hard to see, but it's much easier to see when it's moving video. So the new aspect ratio of 21:9 in the new release of Microsoft Front Row which we're coming on to talk about, has a resolution of 2560 by 1080. So this is the same pixel density as HD. It's got the same vertical resolution, but if you like, with added pixels to express that clumsily on the side. So you can see where that's going with that, where I'm going with that comment. You know, those who can, you know, first deliver a true UHD pixel density, you know, namely at 4 times the resolution of HD, you know, they will have a big advantage, because it, you know, I think we've got to regard it as inevitable that the source resolutions will get up to those kinds of levels. But for the moment, the resolutions is being fed out at around the HD pixel density. So the main takeaways from DISCAS is that users in general need a much larger image size than they generally think. Where I'm going with that in a moment is that you'll see that I think that's become even more significant now, and we're going to unpack that in the slides that we've got coming up. The way that you use a standard, you know, very often, sometimes it's not so straightforward, and you get difficult scenarios. And sometimes, so for example, there might be a bit of a conflict between the need for the furthest viewer to see, or the actual the limit that you want a viewer to be in terms of proximity to the screen. However, you know, what I always do is I go back to, you know, what I call room design 101, and it's just so important to make sure that the people at the back of the room can actually see the content and engage with it. It might be that you have to have viewers a little bit too close for comfort, or a little bit too wide out to the screen. But, you know, the important thing is that everybody in the space can actually see it. Remember that the standard is based on image height, and although it doesn't matter so much now, because for reasons that I'll go into in a moment, 16:10 projection is 8% higher than 16:9 size for size. So although that can be an argument for using projection, in fact, you know, based on, you know, recent dialogue and look at it in more detail recently, that doesn't count for so much. The other point I was making during running through the standard like that is it's important that you make the standard work for you. You know, these are not tablets written in stone. They're useful working documents, and I believe that they should be respectful of the users of the standard's own experience and opinions. But the thing is, you can use it as a device for showing your workings. You say, I've worked through it, but on the basis of this, that, and the other, then it should be, I'm going to make this conclusion. And I think that's completely legitimate in the way that standards are used. And the other thing, as you've seen, is that it can be used to give guidance on existing systems. So the standard's free. It's free to VIXA members only, and hopefully everyone here is a member of a VIXA. If they're not, then there are enough links from this deck to get to that. But if anybody isn't a member and would like to be put in touch with the VIXA office, then please just ping me after this. Coming back to the 16:9 or 16:10 thing, I had a lot of dialogue about that over the last year. And then last year, as a result of that, I just did my homework and wrote a white paper on that. You can download it off that link, but you know, basically the answer is, you know, I'd strongly recommend you to use 16:9 rather than 16:10. If nothing else, apart from the maths involved, the thing to remember is that 16:10 is effectively a temporary resolution. At the moment, there are the projector panels have got WUXGA resolution, namely 1920 by 1200, which is where you get the 16:10 from. However, you know, it's only a matter of time, isn't it, before everything moves to either UHD 4K or full 4K, in which case it'll go back to 16:9 or near 16:9. And for the most part, people who have 16:9 images on 16:10 screens, which often happens, you just get that ugly back band. But just to complicate the whole thing about aspect ratios and image sizes, Microsoft have put out this new front row release last month, in the middle of last month, for Teams rooms. And this front row, this whole front row screen layout supports two aspect ratios. It supports 16:9 at 1920 by 1080, or 21:9, as I mentioned before, at 2560 by 1080. And that's not the only aspect ratio that's out there. So in addition to 16:9, they have this new 21:9, but already in their materials, you can see they've got these super wide displays. In fact, if you look carefully at the Microsoft, they've put together a couple of demo systems at the Hive there on the main campus in Seattle. And they're doing the super wide displays at 32:9 because they've got two 16:9 images hard-ed butted against each other. In our view at Visual Displays, that if you do want to do that nicely, you would want to use soft edge blending in the middle, and that would give you something around 28:9 using standard numbers. However, using two projectors with a blend, you can go to pretty much any aspect ratio that you want. But so apart from observing that these aspect ratios exist, and what I wanted to do was to actually to drill down on that and to think about how this applies to DISCAS. So this is where it gets interesting. Until this year, by and large, screen content height has been synonymous with display height. Content height was the same thing as display height. Well, this is changing, because now we're effectively into picture-in-picture territory. And for any display that's going to stand the test of time for the next few years, they're going to have to be a whole order of magnitude larger than that we've been used to. Even quite small rooms are going to need displays much larger than flat panel displays can provide. And if you look at this this illustration, I've just chopped this from one of the Microsoft Vision pieces. And this is an example, by the way. I haven't put a ruler on it, but the main content. The main content is going to be a picture-in-picture within the overall image area. And if you remember that the important thing is to deliver content that can be read and understood to people at the back of the space, then this means that in many cases, you're going to have to apply DISCAS to that content window rather than the overall display size. And just using this as an example. So if you were going to use the DISCAS percentage element height at the default of 3%, which equates to a 6:1 aspect ratio. If the content window was, say, only 60% or 0.6 of the image height, then this means that ratio becomes 3.6:1. So that is quite a kind of sobering thought to consider. Now we're seeing a lot of noise out there with with clients and consultants. Well, by noise I mean dialogue. We're making these 21:9 displays, but we're doing them by cutting down the a 16:9 screen. That's what we do. However, I just don't believe that this is why I'd like to have time to have a bit of a discussion about this, after the event, because I think it's more likely that people are going to want to have multiple workflows, multiple screen layouts that they're going to be able to use over the lifetime of the display. So you might want to, have a mode of use where you're just having this 21:9 aspect ratio, but other times you just use the whole screen area to, to display content. But like I say, we're really into the kind of the picture-in-picture area here. And so for practical reasons, the way that we're engineering that is to use an external processor and to use that with a single 4K UHD projector. Just thinking in cost terms, it costs the same to make the 21:9 screen in round terms than to have a whole 16:9 image. And for the time being, we just think that, for future-proofing displays, it's just about using a much, much larger 16:9 display. But this, as I say, is a dialogue point. Using projection. DV LED will come into focus at some point, but for the moment, to do with cost and flexibility, I believe that's why Microsoft have made such a big thing about projection. However, we've got to be absolutely clear here. It has got to be projection done properly. The old washed out images that some people are used to seeing are, that they're completely unacceptable in those terms. So these two images here, they've got two things in common. They've both been shot on university campuses, and they've both been shot with iPhones. The image on the left, I'm not going to tell you where the image on the right is, but a lot of campuses or offices have got spaces like that, where the facilities management, the building management kindly spend extra money on providing lighting to kill the display that they've spent money on producing. But moving swiftly on, the image on the left is at Glasgow University. That was taken during a sign-off. I was out there last week shooting video with a crew for the case study, but we've got 30 of these visual displays, digital canvas displays up there, and they range from 100 inches a diagonal up to 8 meters wide. And this was this is a project which we're going to use very much as a Trojan horse, as a kind of an evangelizing piece to show how projection could and should be done properly. And it's a very good example, because we're very proud of it, because it was the image is way better, it's way more suitable than DV LED, and it's also way more cheaper, more cheap. But when it comes to doing projection done properly, then the really important thing is to choose the screen material first. It's all about using ambient light rejecting projection surfaces. That's a non-negotiable now. The only negotiable thing is which flavor of them, which type you want to do. So you choose the size, you choose the screen type depending on the application and the location and so forth, and then you do the maths. You work through the calculators and so forth to do with projector lumens, with the projector contrast and so forth. Now we do that with our for our partners, but that is that's the process that has to take place. Right now, so this is just to be absolutely clear, this is the part of the presentation where I'm actually going to start selling to you and telling you about what we do. So we've been thinking and some of these challenges that Microsoft have thrown up. And so this is not just doing projection done properly. We think that there'll be a move to these what we call our VDL digital canvas, where they are built as all-in-one units, as pieces of furniture, with with a projector with an ultra short throw lens on there. We do them in a variety of finishes. You can have the camera fitted to it. We do them flat pack for export, and part of our design consultancy is that we can do industrial design to make these fit certain environments. Looking to the future, although we are actually working on projects now that will have these, we also feel that in some cases it will be a nicer, a better user experience to have the screen curved. And there you can see, one of the designs that we have, and that we're currently working with some clients to produce those as working models. The idea is there's more reciprocity in the experience. The remote and in-person participants feel more equal. It's a kind of hopefully a more organic and human-friendly configuration. Whether you use, we call the furniture the credenza type units, so the digital canvas, and then in the cases where you've got the usual projectors from the ceiling and screens hung on the wall, we call that digital canvas core. That has a bearing, on how much radius you can use and what kind of curved screens that you can have. But these are all based on our simulation tools. We've been making curved and immersive displays for many years, and we have a really quite substantive IP and calculation tools to do that. And that's part of the design consultancy that we offer. And it's that background in making immersive spaces that brought us to that point to be able to offer the curved displays. So just as a kind of a final sales piece, word from our sponsor, if you like. What we're seeing is that we are seeing a lot of a real major trend where organizations are now installing evaluation and laboratory zones to test the systems and displays. And we're working extensively with all parts of the food chain to do that. And that's one thing that is a real specific that we seem to be working on a lot at the moment. For those of you who are here who are end users, it doesn't matter where you are globally, but for those of you who aren't already members, I strongly advise you to get involved with the AV user group. That's my friend Owen Ellis there, who runs that. I think we've got some other members here from the group. And the other association for those of you who are on the education side, in the UK, the technology managers group for university campuses is the LTSMG, Learning and Teaching Spaces Management Group. They are, these are the people who run the tech on campuses. So for those of you who are in academia from not a member of that, I'm very proud to be associated with both the AB user group and the LTSMG, and I strongly advise you to get involved with that. And then finally, just to say what we can do at Visual Services. So we do a lot of things, and the point that I wanted to make really with this slide is that it's a kind of a patchwork thing. Our clients are welcome to use any or all of our services as it breaks down and as it is appropriate for for the projects that we need to be involved with. We work actively with all parts of the food chain, from end user through to reseller. A lot of work with and in support of consultants. But having said that, all the hardware and solutions that we make are supplied through the reseller and integrated channel, as befits our role as a specialist manufacturer and distributor. So that's it with my slides, and I just was hoping that we might get some Q&A some questions about this, because I'd be very interested to hear what people's views about where we're going to go with image sizes, what the challenges are going to be with image size with regards to what is happening with Teams rooms. And of course, that's going to be be the same for Zoom and WebEx and so forth. I'm just using that as a main example. Right, let me see, we've got a question here. How do you get, this is from Anonymous. So how do you get individual far end camera feeds separate to content windows from single MS Teams endpoint PC? I think that the whole thing about camera position is that's very interesting. Let me just kill that and go back to looking at guys. One thing that Microsoft are doing effectively, as you can see, is that they're effectively embedding the camera in the screen. We think there's going to be a lot of movement in that, and that's one of the reasons why we're making the digital canvas with the ultra short throw projectors, is it will allow us to actually inset a camera into the screen without the projector shining onto the lens. I think that the other thing that will happen is that the camera will move into free space in front of the screen. I'm thinking about Huddly here, but of course other brands are available. But what you're talking about is very high resolution, small form factor cameras, which can be placed in various positions. And I think that one of the, so long as the camera can be, sufficiently small form factor, I can just see those being positioned in free space in front of it. There's in many ways that it's not ideal to have the camera right at on one wall of the space in any case. So I think there's also an argument for doing it. But I think this is something that I'm seeing with the various clients and colleagues who are making these lab spaces, because this is very much work in progress, and people are looking to refine and to be able to be able to work on all of these aspects to the hybrid spaces to gradually incrementally improve them. Pete, you have something to say here. Not only the smaller content window due to Teams room front row decreases the character type, but also 4K displays present fonts a little bit smaller than full HD, which is our standard due to scaling. No, absolutely right, Pete. So Pete, if I'm going to explain your point correctly back to the group, then if you just feed content into a 4K UHD display, then it will tend to show it smaller, and that's one of the reasons why we use a separate scaling device in the system architecture, because I think that is very important. So that is something that I basically agree with, but I think you also need to factor that. And Peter also asks, how many participants would be the maximum number for such reciprocity meetings within a room? Well, honestly, Peter, I can't answer that one on the fly. I think that the really interesting thing about the 21:9 aspect ratios, I think it's a very good compromise. The issue that I have with a room that was set up purely just for front row is that by definition you just kind of have one row of chairs or maybe two, and you're going to be spending a lot of money to have a space that will only service a relatively small number of individuals. Now, some of you may know I'm really not a big fan of the twin displays that a lot of people are using in those spaces. it's very hard to get them big enough to show content to the back of the room. If you do get them the right size, then it kind of pushes the sides out, further into the sides of the room, so that the people at the front of the room will block the view of the people at the back of the room. And I just think that 21:9 aspect ratio would be an aspect ratio where you could support both that kind of front row configuration, where you've just got a single line of people in front of the display, but also a full table as well. And I just I can't speak for Microsoft, but I think a lot about what they put out and what they do. So that's my my thought there. Right, have I got any more questions? So, Pete, this is fantastic what you're saying. So, you're definitely my best friend this afternoon, Pete. So you're saying we like to have multiple screens, more than one camera at a time, of a student team to the far end, dependent on the education practice. But then you have to make logins on the same session, or do you have an idea? Okay, Pete, this is actually bang on the money. Just from a practical perspective, if you look at the vision for what Microsoft are doing with these big front row displays, I just don't see it being supported by a single feed. If we're going to go to those megapixel displays and at a reasonable frame rate, I just think we're back into the world of multiple codecs, of multiple sessions. Now that won't be very convenient for corporate, for Microsoft maybe, who are thinking about the corporate world. But I think this is where the opportunities lie on campus, because this is such a brave new world where people are working these things out. But I think I'm on the same page with you there, Pete, because I think that the idea that you're going to be able to do these large complex displays with a single stream, with a single feed, that is the question. Now, Microsoft are already and Microsoft are just now supporting 2 cameras, I believe. I think Zoom already supports multiple cameras, so the actual number of cameras can be supported better. But I think, again, this is why people are putting in these experimental spaces, because there's a lot of discovery to be done here. Alexander from Düsseldorf, thank you. Nice to see you, and thank you for your question. So is there a standard or calculator tool for the amount of light in a teaching space? Stage light for video camera, PTZ, versus a low light on stage for projection? It's a brilliant question, Alexander, and the answer is yes. So that really falls outside the AVIXA standards, but it connects to them. Now, there are a number of environmental lighting standards. In the UK, we have the Society of Light and Lighting, and they produce, they're part of SIBSI. They produce the lighting guides. In the States, there's the IES, but the really big news with environmental standards is the advent of the WELL standard, particularly the new WELL version 2. And what we do is we use a task luminance calculator, task luminance ratio, to set the amount of luminance that you need to fall onto a space. And it's not just the amount of light, it's the direction of light as well. So the quick answer, Alexander, is that there is a standard there. But if you'd like to drop me an email or a message on LinkedIn, I'll send you some more things about that. I also do webinars about meeting space design, where I talk about that in particular, and I think I'll probably cover that in a slightly just at least peripherally, and on the webinar I do on Thursday. So I think I'm happy to stay around for as long as anyone there, but I think that's the end of the the questions. That was really helpful for those of you. Oh, we've still got quite a few people on the call, but that was really helpful to me. I don't see this as a clear answer. I think that honestly, I think we're all learning about this, and you know, so I'm really grateful to have any dialogue and debate and input from anyone. But that was very stimulating for me. I'm going to stick around for you know, for a little while, for another couple of minutes. But it looks as if the questions are over. I've gone over the hour, as I was happy to do. I can still just about talk, but I think we're getting close to the end of that. So while just waiting for everyone to go off, and there's some lovely comments in the chat, and that's really nice, and so nice to see so many you know, old and new friends there. This has been a really you know, happy thing for me to be doing these webinars, because it's really helped me to organize my own thoughts. There's been a lot happening here. There's a lot in terms of at Avixa where we are thinking about the next phase of standards, where we're going to go with that in my own professional work, and actually just working with my clients. It's been really helpful to do this, and having this this dialogue, particularly on these sessions, has been really good. So now I'm going to sign off. Thanks again to everyone for attending. You will get the materials after this. That we'll pull them together over the next day or so and get them out to you. I'm doing another webinar on Thursday, which will be basically a kind of a pull together of a number of the webinars we've done so far, but with some of these new dialogue elements that are added into that. So hopefully I will see some, if not all of you there. I'd like to thank everyone again for attending. That was very enjoyable. I'm sorry if the slides dropped off at some point. I was trying to be clever, moving between different packages to show you things. But thanks again, and hope to see you on one of my other webinars very soon.